Hey guys, welcome to another lecture from Introductory Statistics. And today we will be continuing with our discussion on probability distribution function and discrete random variable. Today we are doing a very important concept, the concept of cumulative distribution function. You have understood probability distribution function and the probability distribution table, then CDF will be very simple for you. But yet there are certain things which are very important here. Now, why are we talking about cumulative distribution function? As the name suggests, cumulative, it will be about adding up probabilities, accumulating probabilities. Because, many a times what happens is for some fixed value of x, often it's not that we just want to know what is the probability at x. We would probably want to know what is the probability at most x in order to compute the probability that the observed value of x is at most x. The concept of CDF is used. Let me take you through an example to simplify everything. Consider the following PMF. Suppose you have a probability mass function. X is taking three values 0, 1, 2, and it is taking the values with certain probability 0 with 0.5, 1 with 0.167, 2 with 0.333. And say you are interested in figuring out what is the probability x is at most 1. At most 1 means that at the maximum x is 1. That is, x is less than or equal to 1 always. So you will have to think what are the values that this random variable x is taking that are less than 1? Less than or equal to. This equal to is very important here. Well, x is taking value 0, which is less than 1, and it's taking value 1. So when we say x is less than or equal to 1, it will absorb both the cases, x equal to 0, x equal to 1. Which means that all I have to do is I have to add up, accumulate the probabilities P0, P1, and that turns out to be 0.5 plus 0.167. So it is 0.667. Say I'm interested in probability. X is at most 1.5. Carefully understand this concept. I am interested in probability X is less than or equal to 1.5. Or what you have to think is, what are the values that this random variable X takes, which are less than or equal to 1.5? Well, it takes the value 0. 0 is less than 1.5. It takes the value 1, which is also less than 1.5. Is there any other value that it is taking which is less than or equal to 1.5? Well, no. So again, all I have to do is I have to add a P0, P1. And that turns out to be the same thing, 0.667. So what you observe is that this probability x is less than or equal to 1.5 turns out to be same as less than or equal to 1. Now say I'm interested in probability x is at most 2. That means I'm interested in finding out what is the probability x is less than or equal to 2. Probability x is less than or equal to 2. What are the values that x is taking that are less than or equal to 2? Well, x is taking 0. That's less than 2. X is taking 1. That's less than 2. And x is taking 2. That is less than or equal to 2. So therefore, I have to add up P0. I have to add up P1. I have to add up P2. And that would be 0.667 plus 0.333 gives you 1 because these were the three values that x is taking. It's not taking any other value. So, of course, the total of these, since this is a probability mass function, the total of these probability will be 100%, that is equal to 1, right? Now, say I want to, within this example, want to ask you what is the probability that x is taking less than or equal to 4. Probability x is taking values less than or equal to 4. Well, it will be probability x is equal to 0 plus probability x equal to 1. That's less than 4. Probability x equal to 2. Is there any other value that x is taking which is less than or equal to 4? Well, no, it's not taking any other value. And all these values are less than or equal to 4. So this will turn out to be 1 because it's the sum of the entire thing. What you would notice is that when x is equal to less than or equal to 4, the probability is actually same as the probability x is less than or equal to 2 that we calculated. Similarly, if I ask you x is less than or equal to 20, 200, anything, 1000, whatsoever, x is taking only these three values and all these three values are less than or equal to 20. For all other values of x, the probability is 0. Okay, so therefore again this will be 1, which is basically probability x is less than or equal to 2. So probability less than or equal to 2 is equal to 1. And if you take any value of x which is more than 2, and you are trying to find out probability x less than or equal to that number, you will only get 1 because it's not, nothing is then adding up. Okay. So one important thing that you must have observed in this example is that probability x is strictly less than 1 and probability x is less than or equal to 1. Since 1 is a value that x is taking, these two will be different. And how? This probability x is less than or equal to 1 will be higher. Probability x is strictly less than 1 will be lower than probability x is less than or equal to 1 because you're adding up the probability at x equal to 1 and x is taking value 1. So when x is a discrete random variable and x is a possible value that random variable x can take, then probability x is strictly less than x is always strictly lesser than probability x is less than or equal to x because this lowercase x is a value that x is taking. So this probability will automatically turn higher. Okay. Now, with this knowledge, let's jump onto the concept of cumulative distribution function. Cumulative distribution function, as the name suggests, talks about accumulating probabilities. It is denoted as capital F, generally capital Fx for the random variable here, value of the random variable x here, or it could also be just written as Fx. But capital F, we write it down as capital F. And this is nothing but probability of the random variable x till the value and including x, the number that you will feed in here. Okay. So cumulative distribution function, more formally CDF of a discrete random variable with PMF Px is defined for every x by capital Fx, which is equal to probability x less than or equal to this value x, which is the sum of all the probabilities, probability say y, where y is less than or equal to x, where y we are taking as the domain and nothing else. So for all the values less than or equal to x, you will add up the probabilities to get the CDF. Let me give you an example to make it more clearer. A store carries flash drives with either 1 GB, 2 GB, 4 GB, 8 GB or 16 GB of memory. Let y, the random variable, be the amount of memory in a purchased drive. So somebody who's purchasing a drive from the store could purchase 1 GB, 2 GB, 4 GB, 8 GB, 16 GB. So there would be a probability attached to the customers. Okay. Now, what values can y take? Y is the amount of memory. So memory could be 1 GB, 2 GB, 4 GB, 8 GB, 16 GB. So y can take values 1, 2, 4, 8, 16 and suppose the probability attached to each of these values is the following. So this is the probability mass function. 1 comes with probability 5%, that is 0.05, 2 with 10%, 4 with 35%, 8 with 40%, 16 with again 10%. So please try to understand here. This basically means that from this shop, when we are taking the data, 5% of the people are taking 1 GB hard drive. 10% taking 2 GB, 35% taking 4 GB, 40% taking 8 GB, 10% again taking 16 GB. And this total will surely be equal to 1 because this is how the data is divided. Because we just have 1, 2, 4, 8, 16 GB drives. Okay. Now, let's calculate the CDF for this random variable. So let's calculate capital Fy. I can write down Fyy or just Fy. What I would be interested in is in finding out capital F for the values that this random variable is taking. So I'll be interested in F1, I'll be interested in F2, I'll be interested in capital F4, I'll be interested in capital F8, I'll be interested in capital F16. Now capital F1 means probability y is less than or equal to 1. So you will have to think, what are the values this random variable y is taking which are less than or equal to 1? Well, it's only taking 1 because the value starts with 1, right? So it is P1 and P1 is given to us as 0.05. So that means capital F1 is also 0.05. Now F2 is probability y is less than or equal to 2. So you will have to think, what are the values this random variable y is taking which are less than or equal to 2? So it's taking 1 and 2. So that means probability y equals to 1 plus probability y equals to 2 should be added. So P1 plus P2 gives you 0.05 plus 0.1 gives you 0.15, 15%. F4 means probability y less than or equal to 4. That is equal to, you'll have to think what value y is taking which is less than or equal to 4. It's taking 1, 2 and 4. So P1 plus P2 plus P4. And that gives you 0.15 plus 0.35, that is 0.5. F8 means probability y is less than or equal to 8. What values y is taking which are less than or equal to 8? It's taking 1, 2, 4 and 8. So P1 plus P2 plus P4 plus P8. So 0.5 plus 0.4, 0.9. Probability y less than or equal to 16, that is capital F16. So what values is y taking which are less than or equal to 16? All these values, right? So P1 plus P2 plus P3, not P3, plus P4 plus P8 plus P16. That means 0.9 plus 0.1 gives you 1, right? So what are your CDF values for the values that y is taking? Following values. What is interesting to figure out is the following. Suppose I ask you, what is the probability? What is the cumulative distribution function for the value 2.7? That is, what if I ask you what is f 2.7? So you know that means I'm talking about y less than or equal to 2.7, the probability associated to that. So what will you have to think? You will have to think what are the values that y is taking that are less than or equal to 2.7. So well, it's taking value 1 and it's taking value 2. Both values are less than 2.7. But then there is no other value that this is taking which is less than or equal to 2.7. So it's only taking these two values. That means I'll add up these two probabilities and I will get 0.15, which was same as capital F for 2. Because in that also I was just adding P1 and P2, right? Similarly, suppose say I'm asking you what is capital F for 7.9. That means probability y less than or equal to 7.9. So you'll have to think, oh, what are the values that y is taking which is less than or equal to 7.9? So you will realize 1, you will realize that it's taking 2, you will realize 4 is less than 7.9, but 8 is more than 7.9. So I will not go there. That means I will just add up these 3 and I'm going to get 0.5, which was same as capital F4. That was also just adding these three probabilities, right? So with this, you can actually now learn how to create capital Fx as a function. How do you denote capital Fx as a function? In our case, our random variable was y. So let's take capital Fy. When I say as a function, I mean in the entire domain, how do you define your function? So what I can do is I can divide my domain into certain subdomains. See, y value was y is taking is 1, 2, 4, 8, 16. So I can divide the values as less than 1. Then I can say another subdomain could be y starting from 1 but going only till 2. Why going only till 2? Because the moment I will include y equals to 2, the probability will change. The capital F will change. But till 2, it will not change. Why it will not change till 2? For a simple reason, nothing is being added. As you've seen in the examples out here. Similarly, then I start with 2 and keep on moving till 4 but not including 4. Because at 4 some change is happening, some probability is getting added. And then I start with 4 and keep on moving till 8 but not including 8 because some change is happening at 8. And the other subdomain will be from 8 till 16 and not including 16. And then more than or equal to 16, whatever values it can take later. So what is probability? What is capital F when y is less than or less than 1? Well, if you say probability y is less than or equal to, say we are taking y as strictly less than 1.5. So that means I'm interested in capital F is probability y less than or equal to. So probability y less than or equal to 0.5. I'm just taking a random value which falls under this category. Probability y less than or equal to 0.5 will just be 0 because the value y takes is 1. The first value that it takes is 1. So this will just be 0. For any other value, 0.5, 0.6, 0, whatever you take, your probability will be 0. And then, if suppose you want to know what is f of some value between 1 to 2, let's take 1.5. So capital F 1.5 is probability y less than or equal to 1.5. If you have understood the examples that I gave you, you would have understood the concept out here that probability y is less than or equal to 1.5 will just be probability 1 because y is taking only value 1 which is less than or equal to 1.5. Okay, and then the next value it takes is 2. So therefore f 1.5 is same as f1. And that turns out to be, as we have figured out, 0.05. Now, when y is between 2 to 4, let's find capital F. Let's take a value, say 3. 3 is between 2 to 4. So, this means I'm interested in probability y is less than or equal to 3. So, that will be P1 plus P2 because what value y is taking which is less than or equal to 3? Only 1 and 2. And that gives me capital F2. So for the entire subdomain, when y is between 2 to 4, the probability will be just capital F2, which turned out to be 0.15. Similarly, between 4 to 8, if say you are taking probability, if you're taking capital F of 7, it's between 4 to 8. In fact, 7.9, if you've understood it from that example, it would be clear. We are interested in probability y is less than or equal to 7. What values is y taking which are less than or equal to 7? It's taking 1, 2, then 4. Okay, no other value, right? So this is nothing but capital F 4 because that's what I'm adding in capital F4 also, and that turned out to be 0.5. Similarly, 8 to 16, say if I'm interested in F15, now I'm interested in probability y is less than or equal to 15. What values y is taking which is less than or equal to 15? 1, 2, 4, 8, but not 16, okay? Just till 8. That means I'm adding up till 8, so it is nothing same as F8. So that turned out to be 0.9. And then y is greater than or equal to 16. So let's take a value which is more than 16. So suppose I want to find out F17. So that means I'm interested in y less than or equal to 17. So what values y is taking, which is less than or equal to 17? It's taking 1, 2, 3, 4, 8, 16. So this will be same as F16, because in that also I'm adding just those values, and that turns out to be 1. This is how you can divide your domain into subdomains and correspondingly write down the probabilities, cumulative probabilities, CDF. Let's now depict this on a graph. If you want to depict this on a graph, let's create this graph. So I have values 1, 2, 4, 8, 16. So I'm going to take it like 2 here, 4 here, 6, 8, 10, and somewhere 16 somewhere out here. Okay. Say 16 is here. Then I have 0.05 and so on. So let me take 0.2 here, 0.4 here, 0.6 here, 0.8 here, 0.1 here, not 0.1 here. Okay. So when x is less than 1, the probability is always 0. So mind you, this is y and this is fy, value that y is taking. F, capital F is the function. Now, at 1, suddenly capital F becomes 0.05, say out here. Till 2, it remains 0.05. And then suddenly, what happens? At 2, the probability changes, capital F changes, it is 0.15. And till 4, it remains 0.15. And then what happens? Till 4, it will be like this. And at 4, suddenly it's turning into 0.5. And till 8, it is 0.5 only. Just that at 8, what happens? At 8, in F8, you will have probability 8 added. And you are getting 0.9. Till 16, it remains 0.9. But at 16, it changes. It turns into 1 and then it stays 1. What do you observe here? Very interesting thing. This is a step function. So for x, a discrete random variable, the graph of capital Fx will have a jump at every possible value of x and will be flat between possible values. Then that means anytime this kind of scenario is occurring, the function will be a step graph. And capital Fx, when it comes to discrete random variable, is a step function like this. I hope with this, you will have a clarity in terms of what CDF is and how you graph a CDF for discrete random variable. How do you write it down as a function? Thank you very much. I hope this will really help you guys.